Good evening, children.
Good evening, ma'am.
Evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Yes, children, we are continuing with similar triangles. Yeah. So see this figure here. You don't see any question there. You don't see any question there. But you have to show that the question is to show that triangle PQR. You can just take down this diagram and you have to show that triangle PQR is similar to triangle ABC. Is similar to triangle ABC. You can see here, this is the question. Show that PQR is similar to ABC. This is the question. Show that the figure is given to you. You will have to show that triangle PQR is similar to triangle ABC. So see here, find the ratios. Find the ratios PQ by AB, 2.3 by 4.6, 1 by 2. Then QR by BC, 5 by 10, 1 by 2. Did I say 1.2 here by mistake? I don't know. 1 by 2. 2.3 by 4.6, 1 by 2, 5 by 10, 1 by 2. Then find the ratio PR by AC, 4 by 8, 1 by 2. So you can see in the numerator, PQ, QR, PR are the sides of the inner triangle PQR, and the denominator AB, BC, AC are the sides, the corresponding sides of the outer triangle ABC. So we see that the ratios are the same. So we see that in triangle PQR and triangle ABC, these three ratios are the same. PQ by AB is equal to QR by BC is equal to PR by AC. So that is their corresponding sides are proportional. Therefore, by SSS similarity criterion, the two triangles are similar to each other. Is the first one. See the second one here also. We have to prove that ACB, this one, ACB is similar to DCE. ACB is similar to DCE. So you have two sides. You can make out, no, see 1 by 6, 3 1 by 2. 1 3 by 4 and 2 1 by 3. Like 1.1 3 by 4 is like 1.75. Double it, you will get 3.5. You will get 3.5. So when you this one doubled is this one. So mostly this one double should be this one. So find the ratios. So find the ratio. So I found as AC by not 1 second. It's like this. I found AC by CD. AC by CD. 1 3 by 4 divided by 1 by 2. You can see the working here. Then find BC by CE. BC by CE. BC by CE. So do that and you get 1 by 2. So clearly in the two triangles, these two ratios are the same. AC by CD is equal to BC by CE. In the numerator, we have the sides of the small triangles here. AC and BC we have in the numerator. AC and BC, the sides of the small triangle. And in the denominator, we have the corresponding sides of the larger triangle. So we have CD and CE. We have CD and CE of the other triangle. Okay, so the ratios are the same. In the two triangles, the ratios. Which are the ratios? These two ratios. This one is 1 by 2. This one is also 1 by 2. So AC by CD is equal to BC by CE. All right. Now I'll tell you why I have written this. This is enough, but I'll tell you why I have written this. Now coming back to the first one, children. Coming back to the first one. So how do we write the order? Meaning, how do you name the triangles in the correct order? One thing is it will be given in the question, so you're going to write it as it is. In the question, it will be given to prove that triangle PQR is similar to triangle ABC. So you're just going to write that. That's one thing. But how do you identify the correct order? So see, here it is simple because PQ, QR, PR goes with AB, BC, and CA. So it's ABC and PQR. But otherwise, you can use the ratios. Just take any two ratios. Take any two ratios. Supposing you take. Okay, so supposing you take the ratio PQ by AB and QR by what is it, BC. Okay, supposing you take the ratios PQ by AB and QR by BC. So again, like I told you in the last class, in the numerator, Q is common. So see here PQ, QR. So like PQ, QR in the numerator. So PQR. And in the denominator, it is AB, BC, like AB, BC, which is ABC. So PQR is similar to ABC. Okay, so you can write it in different ways. You know that you can write it in different ways. Supposing you say QRP, QRP, QRP is similar to BCA. BCA is also correct. If you write RQP, RQP in the reverse order, RQP similar to CBA, CBA. So the order is very important. You can write it in different ways. Supposing you take up these two ratios. Okay. So then you have QR by BC is equal to PR by AC. So which letter is common? R is common. So we'll write this one as RP. PR, RP both are the same. And we'll write this AC as CA. AC, CA both are the same. So in the numerator, what do you have? QR, RP. So it's QRP, QRP. And in the denominator, we have BCCA, BCCA, which is BCA, BCA. So QRP, QRP similar to BCA is also correct. So just take any two ratios and do this, you will get the order. See here, if you write, this is 1, 2, 3. This is 1, 2, 3. Okay. So now if you want to write PQR, PQR from this, if you want to write PQR, P is 3. Q is 1, 3, 1, 2. So here also 3, 1, 2. 3 is this one, 1 is this, and 2 is this. So see a PQR similar to ABC. So in the second one, we have corresponding sides proportional. Okay, and the included angles equal. I've marked here angle 1 and 2. I've marked here. See, I've called this angle 1 and this one angle 2. Angle 1 is equal to angle 2. Vertically opposite angles are equal. And they happen to be the included angles. Okay, they are the included angles. So because in the small triangle, we have mentioned about these two sides. So this is the included angle. In the other triangle, the big triangle, we have mentioned about these two sides. And this is the included angle. So by SAS similarity criterion, these two triangles are similar to each other. Yeah, so this may be very simple for you because you've learned much more in similar triangles. But anyways, please make a note of this, children. Quickly write down this. You should not write like this. You must not write in the beginning itself. You should not write PQ by AB is equal to QR by BC is equal to, because sometimes we know you should not write like this, but then we make this mistake. You should not write like this and then write 2.3 by 4.6 is equal to 5 by 10 is equal to 4 by 8. This is not the correct presentation, because when you start off, you don't know if these ratios are equal. When you start off, you do not know. Only when you simplify, it's like only when we simplify, we realize that all the ratios are equal to 1 by 2. But when you start, we don't know if they're equal. So you should not write like this. PQ by AB is equal to no. Then writing 1 by 2 is equal to 1 by 2 is equal to 1 by 2. No, this is not the correct presentation. You have to find the ratios separately. You should find the ratios separately. You're finding PQ by AB, then QR by BC, then PR by AC. And then only you realize, after finishing everything, you realize that, okay, all of them are equal to 1 by 2. So only after this, you realize that all these three ratios are equal. Write down, children, quickly. And children, I know, the physical sessions are just getting delayed, but one last thing has to be done. I need to get the projector installed there because I have to do online and offline at the same time. Without that, the online students cannot, meaning cannot take up the class. So tomorrow, the revision program for tomorrow will again be online. Um, I most it will be ready next Sunday because I've been saying this, so I'm really finding it hard to repeat that. But next Sunday the session will be a physical session. I'm sure it should be ready by then. So it's almost done. Just this projector work to be installed there. Yeah. So tomorrow I'll share the details about the revision program class. Mostly it will be in the evening. I'll just share by tonight. Say okay, no?
Yes, ma'am.
Yes, ma'am.
Okay, ma'am.
Yeah, thank you. Yeah, children, please write down this. Done, children? Done writing?
1 minute.
Okay.
Done, ma'am.
Okay. Yeah. So see here in this figure, again, you'll have to prove that they are similar. The first one was using SSS. This one is SAS. Now you can see the other one here. So in these two triangles, you can see this angle is 57 degrees. This is 45. Here 45 and 78. You will have to show that these two triangles. This is the question, children. Right below, you see here. This is a show that triangle XYZ is similar to triangle RPQ. Right. So we'll find the third angle. We'll find because you know nothing about the sides. You know nothing about the side, so we have to only work with the angles. So we'll find the third angle in both the triangles. So this is computing the third angle Z in the first triangle, and this is computing the third angle R in the second triangle. And then you know what to do. After that, you know. So in the two triangles, any two is enough. Any two is enough. Double A is enough. I've just mentioned for triple A. So in the two triangles, you can see that we have 57 here and 57 here. You can understand this. So triple A similarity criterion, the two triangles are similar to each other. So sometimes you may have to find the third angle. Okay. Because as of now, we have only two angles. Given is, we can see only 45, 45 equal. Here, we only see 45, 45 equal. Then we need one more pair of equal angles, which is not available as of now. So you have to find the third angles in both the triangles. That's about the third one. In the fourth one, again, this is the question, children. Show that. Okay, and the order. The order is very easy, you know, third one, because this is what is the measure here? What's the measure here? Z is 78 and this R is 57. So just match the angles. So if you say XYZ for the first triangle, similar to X is 57, R is 57, so R. Y is 45 and P is 45, so P. Z is 78, Q is 78, so Q, Z with Q. X and P are, these two angles are equal, Y and P angles are equal, Z and Q angles are equal. Okay. The next one, again, the triangles, ADE, you have one small triangle here, ADE, and one whole triangle, ABC. Okay, two triangles similar because in the small triangle, this is 60. In the big triangle, this is 60. In the small triangle, we have this angle, and the big one also, we have the same angle. So common angle. Common angle. ADE, the small triangle, ABC, the big triangle. Already these two angles are equal because 60 degrees each. And then this is the common angle. So the two triangles are similar by AA similarity criterion. So if you see here, the sides are not proportional. So the two triangles are not similar. The sides are not proportional. You can just find the ratios in your mind. You can see that, you know, the ratios will not be the same. There's no working for this. Or you can just take some three ratios and show that they are unequal. That's all. And the next one is, sixth one is by using BPT. Okay, a line drawn parallel to one side of the triangle. If a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, the other two sides are divided in the same ratio. So you can see here, ED, DE is parallel to, okay, ED or DB, whatever. This one is parallel to this one. So by BPT, you have AD by DC is equal to AE by EB. By BPT, we have AD by DC is equal to AE by EB. So you have to write the proportion by BPT. And yeah. Yes, children. Please work them. 3, 4, 5, 6. Done, children?
No, ma'am.
Okay. Okay, class, use the emoji. Raise your hand. Priyanka, Shreyas. Are you there, Shreyas? Okay, good children. Yeah, please continue. Done, children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. So in question number 6, to find the value of x, we use BPT. We use BPT. You don't have to show the triangles are similar. Since DE is parallel to CB, it's marked. You can see here, it's marked. So you can, when you're in a triangle, when you have a set of parallel lines, you can use BPT. In a triangle, if you have a set of parallel lines, so like see here, if this line is parallel to this line, or triangle, there's a line like this is parallel to this, or triangle like this, parallel. So in a triangle, when you have a set of parallel lines, you can use BPT and get a proportion. You can use BPT and get this proportion. Once you write, so this proportion is like an equation. Proportion is nothing but an equation here. So when you substitute the values given, you can find the unknown. On substituting, you get an equation on x, and on solving, you find x is equal to 2. So before this, you can write in triangle ABC. See, you can just start like this. In triangle ABC, DE is parallel to CB. Therefore, by BPT, you can just mention this. In the triangle, these two lines are parallel. DE is parallel to CB. So by BPT, we have this proportion. Yeah, this I have nothing to see. I won't waste your time by simply saying something which you can easily understand. Please try this, children. Any questions you can ask me. Work the 7th and 8th one. Okay, I just want to say this one. It's given that quadrilateral ABCD is, see, it is, the figure is given to you. Okay, find XYZ if quadrilateral ABCD is similar to quadrilateral PQRS. It's given that they're similar. If this quadrilateral is similar to this one is given to you. Since it's given to you, you have the proportion AB by PQ is equal to BC by QR is equal to CD by RS is equal to AD by PS. Because again, in similar quadrilaterals, the corresponding sides are proportional. Like in triangles, here also, the corresponding sides are proportional and the corresponding angles are equal. In similar quadrilaterals, corresponding angles are equal and corresponding sides are proportional. So we have this proportion here because the quadrilaterals are given to be similar to each other. So you can write this proportion, substitute the values and find the values of X, Y, and Z. So here also, children, find X and Y if ABC is similar to PQR. It's given that ABC is similar to PQR. So since the triangles are given to be similar, AB by PQ is equal to BC by QR is equal to AC by PR. You can write the proportion because the triangles are similar. Because in similar triangles, corresponding sides are proportional. In similar triangles, corresponding sides are proportional. So write this proportion. Yeah, and then substitute the values and you will know what to equate to find XY, to find X and Y. Yes, children, do this. And let me know once done. Done, children?
No, ma'am.
Okay. Any doubts, children? Please ask me. So in the first one, you have a complete fraction or a ratio in 20/7. So equate to 20/7. So see, when you equate these two, if you try to equate these two, you cannot find anything because you don't know x and y. So there's no point equating these two. You have to equate. First, you have to equate 16/x to 20/7 to get the value of x. So I have equated everything to 20/7, but actually, once you find x, so you know that x is 28/5. So this is 28/5. So then you can even equate these two. Once you find the value of x, to find x, you have to equate these two. You have to do that. Now you got the value of x. So this one is nothing but 28/5. So now you can equate these two also to get y. And once you get the value of y, you can equate this with this to get z. So you can do it in different ways, but I have equated everything to 20/7. Find x.
By 6.
Sorry, yes. Oh, there's something missing here. I've erased and then I've forgotten to write. Oh, what should it be? 50/3z is equal to 20. 50/3z. Okay, z is equal to
3 into 20, which is 35/6.
oh, yeah, 3 into 20. 0, let's cancel. 35/6. Oh, yeah, correct. So I must have gone wrong in calculating. So using that whitener, I'd have erased it and then forgotten to write. Okay. Yes, children. Let me know. Once done.
Done, ma'am.
All right, yeah. Others?
Yes, ma'am.
All right, yeah. I think the 10th one, we finished it in the last class. Very important question, very simple yet important. The 10th one, we finished that in the last class. Do the 9th one now.
9th one also we did last class.
All right. Oh, fine, fine, fine. 9 also. Okay. Sure, others?
Yes, ma'am.
Okay, okay. Thanks, Rajeshwari. All right, fine. So 10 we finished. 10 we finished in the last class. Let's just recall 10. So we understood two methods. We have to show that this right triangle ABC, this right triangle ABC is similar to this right triangle, whatever, DEC. All right. So for that, both are right triangles. So directly we have angle 1 is in this triangle, angle 1 is 90 degrees. In this triangle, angle 5 is 90 degrees. See, we have to number it. The numbers will not be given. So you number it like that. So angle 1 is 90, angle 5 is 90. Fine. One pair of equal angles we have. Now the sides are not given. Sides are not known. So you have to use the AA similarity criterion, AA or AAA, whatever. Because nothing is known about the sides. You do not know the lengths of the sides of the triangles. So SA is ruled out. You have to use AA. So you're looking for one more pair of equal angles. So option 1 is, I told you, two lines. See, these are the two lines, AB and DC and DC. AB and DC are the two lines perpendicular to the same line BC. AB and DC are two lines perpendicular to the same line BC. So they are parallel to one another. Two lines perpendicular to the same line are parallel to one another. So that way we have AB parallel to DC. They're parallel. Or you can also say this is 90, this is 90. So 90 plus 90 is 180. Co-interior angles are supplementary. That means AB is parallel to DC. That's what you can see here. That's what you see here. 90 plus 90 is 180. Co-interior angles are supplementary. Then the lines AB and CD have to be parallel to each other. So then take up the two triangles. The two triangles, you can see 90 degrees. And then angle 4 is equal to 2. Parallel line, transversal, parallel line. You can see the Z here. Parallel line, transversal, parallel line. So this angle is equal to this angle. Alternate interior angles are equal. So 2 is equal to 4. So when you mention CED, all this should be about triangle CED and ABC. So which is a triangle you mentioned first? First is CED. Anything can be mentioned first. So CED, the small triangle first and then the big triangle ABC. Okay, so this information here should be about triangle CED. And after the equal to sign, this one should be about ABC. This one is about CED, this one is about ABC. Okay, so 90 degrees and alternate interior angles are equal. We do not know the measure of the alternate interior angles, but they're equal. We do not know the measure. How much they measure, we don't know, but whatever they are, they're equal. Whatever be the measure, they're equal. So AA similarity, the triangles are congruent, similar to each other. The other method is like this. So write out all the pairs of angles which add up to 90 degrees. Write out all the pairs of angles which add up to 90 degrees. So we'll start with 3 plus 4. Angle 3 plus angle 4 is equal to 90. And here we see that angle 3 is in triangle ABC. Angle 4 is in triangle DEC. So 3 is in one triangle, angle 4 is in the other triangle. So we'll use this one for comparing. We'll use this one for comparing. See here, you have to write one equality from, sorry, not an equality. You'll have to write one pair of angles that add up to 90 from triangle ABC, another from triangle DEC, and another which is common to both. Common to both. So in ABC, angle 1 plus angle 3 is no, not 1. Angle 2 plus angle 3 is equal to 90. In triangle ABC, 2 plus 3 is 90. In DEC, 4 plus 6 is 90. And common is angle 3 plus 4 is 90. So you'll have to compare. You'll have to compare this one with this one, the common, and this one with the common, this one. Don't compare these two, you will not get anything. If you compare 2 plus 3 is equal to 2 plus 3 is equal to 4 plus 6, angles, no angles, you cannot see the angles repeated. So you will not get anything. So don't compare these two. Compare. So that's what I've written, common one, this one. So compare the first one. Compare this one with this and this one with this. So you will get two pairs of equal angles. Or if you feel you want to, if you want to use AA, you don't have to write all this. You can just write the common one. Angle 3 plus 4 is 90. Write the common one and then write one more, any one. You can either write 2 plus 3 is 90, or you can write this 3 plus 4 is 90. You can write this one 4 plus 6 is 90. You can write any one of the two. So when you do this, angle 3 plus angle 4 is equal to angle 4 plus angle 6. So angle 3 is equal to angle 6 is the other information. Here you will get angle 3 plus angle 4 is equal to angle 2 plus angle 3. So 3 gets cancelled, angle 4 is equal to angle 2. So you can see 3 angle, this one. Here angle 3 is of the big triangle, 6 is of the small triangle. And here also you can see that angle 4 is of the small triangle, 2 is of the big triangle. So you get one more pair of equal angles. You already have angle 1 is equal to 590, right angle. Now you get one more. So AA similarity, the two triangles are similar to each other. Most frequently asked question, children, please remember this. You must remember the idea. So even if a different sum, not a figure like this, something else with the same kind of information, right? If both are right triangles, but it's given a different way, this idea should be applied there. That is why it is important to revise whatever you have learned in school and the tuition here. Simply, doing many sums, different sums, you're not, going back, you're not revisiting what you've understood. You will not be able to retain the concepts. Simply use your school classwork notebook, which has been taught by your school teacher, and the tuition notebook here. That's more than enough. Remember these ideas. So it may be, it could be this idea, but the figure can be different, may not look the same. But this idea, see, you know that you have to write a pair of angles which add up to 90 degrees from both the triangles. And one more you should write, which is common to both, like 3 plus 4 is 90. And comparing, you know what to compare. So this idea you should remember. So a different figure, but similar information, you'll use this idea. It's all about collecting ideas. You learn different, you get different ideas from, when you understand and revisit different sums. All this you should retain. Is this clear, children? Question number 10.
Yes, ma'am. Yes, ma'am.
All right. So you can see the alternate method here. I think 11 also I asked you to finish, right? If you have not finished, please do it now, children. I'll wait. Please do the 11th one. So whenever you have to find the length of a line segment, like here ED, which is X, similar triangles. See, find X if angle A is equal to CED, that's given. Angle A is equal to CED is given. Done, children, the 11th one?
No, ma'am.
Okay, please complete here. I'll also get back in a minute. I'm sure all of you must have completed.
Yes, ma'am.
Yeah. So here also the triangles, in the two triangles, there's the common angle and another pair of equal angles is given. This is from the big triangle, this is from the small triangle. So they're similar. Match the angles and write the order. Match the angles and write the order. C is common in both. C is common in both. Then in the small triangle, if it is E, in the big triangle, it is A. And now write the third vertex, CE, D in the small triangle, CA, B in the big triangle. Just match the angles. Angle C is equal to angle C, angle E is equal to angle A, and this is the third, these are the third angles. So once the triangles are similar, their corresponding sides are proportional. That is CE by CA will be equal to ED by AB will be equal to CD by CB. Then substitute whatever is given, equate and get the value of X. Yes, similar children. Yeah, so here it's 90 degrees. I've marked 90 here, children. Please do this. Find this is the question. Find AE and DE is the question. The figure is given with all this marking. Numbers, I have used. You should mark the numbers for convenience. This is 90, this is 90. Yeah, do this. And sometimes you have to find, have we done this already, children? I think yes. Okay, don't know.
Yes, ma'am, we have already done this, ma'am.
Yeah, that's what I remember asking you to take a picture of this one and this one in the last class. Okay, yeah, I'll just wait for those who have not finished. Please do it now. All right. So here in this one, see here, supposing you didn't find AB, like you substitute the values given, we prove that the two triangles are similar by AA similarity criterion. And then in similar triangles, corresponding sides are, once the triangles are proved to be similar, their corresponding sides are proportional. So you will write this proportion and fill whatever is given. So and supposing you don't find 13, AB, because AB we find using Pythagoras theorem. Supposing you don't, then you cannot find the value of, AE and DE. Because you cannot equate anything to find the values of AE and ED. Because here AE is unknown, in this ratio AE is unknown, in this ratio ED is unknown, and in this ratio AB is unknown. And how can you find? You can see equating these two will not help you get any value, any missing value. So you must remember that, whenever you can find something, now here by Pythagoras theorem, you should find. Everything will not be provided in the question. Sometimes you'll have to use some other, theorem or some other idea to find the missing side. So here in this one, we find AB because, this is 5 and this is 12. It's a right triangle. So we find the hypotenuse, the length of the hypotenuse AB using Pythagoras theorem. Yeah. Actually, maybe I forgot to, mention that I've directly written 13. I might have forgotten to write it earlier. So that's why I've written note. Don't do all this in the exam. Don't write this note to your teacher. Note AB is 13 by, don't do that. You should write it here. See, like when you write this proportion, you realize that AB you have to find. So work that. Work it here. Find AB and then you continue the proportion. This must be worked earlier. You must show that AB is 13 using Pythagoras theorem. Yeah. Area, so you don't have areas. So we'll I'll let you know. So here, see the statement. I forgot to write the statement, so it's here. It's here. Okay, you'll have to prove that. What you should prove? You should prove that the ratio of the corresponding sides is the same as the ratio of the corresponding medians. So before that, let's talk about. Okay. So when you take two triangles, ABC, PQR, PQR. Now, ABC is similar to PQR is given. So the side AB corresponds to the side PQ, BC corresponds to QR, and AC corresponds to PR. Now, when we say altitudes on the corresponding sides, okay, so now if I suppose take the altitude on AC in the first triangle, if I take the altitude on AC, supposing I draw this one, altitude on AC, AC corresponds to which side? AC corresponds to PR. So here also it should be altitude on PR. It should be altitude on PR. These are the altitudes on the corresponding sides. BM and QN are the altitudes on the corresponding sides. Corresponding sides meaning AC corresponds to PR. See here. AC corresponds to PR. AB corresponds to PQ. And BC corresponds to QR. So that's what we mean by corresponding sides. So the side BC, see here, BC corresponds to QR, So if you take the altitude like this on BC, the corresponding altitude will be the altitude on QR. So same thing holds good for medians and angle bisector segment. So here you have three things: medians, angle bisector segments, angle bisector segments, and altitudes. Altitudes is what I just told you. So when you take an altitude in the first triangle on a particular side, then in the second triangle you should take the altitude that falls on the corresponding side. Medians. Again, triangle ABC is similar to triangle PQR. ABC is similar to PQR. Okay. So the side BC corresponds to QR. BC corresponds to QR. So if you take the median on BC, median, if I say AM is the median, that means M is the midpoint of BC. Altitude means 90 degrees. But median is not 90, but M is the midpoint of BC. So when you take the altitude AM on BC, here you must take the altitude on QR. So median on QR, the corresponding side QR. Here it should be on QR. Okay, so the the median AM corresponds to the median PN because they fall on the corresponding sides BC and QR. ABC is similar to PQR. So BC corresponds to QR. So AM is the median on BC. Here PN is the median on the corresponding side QR. Then angle bisector segments. Medians, median meaning midpoint, okay? Altitudes 90 degree. Angle bisector segments. Angle bisector segments. Okay, so it's given that ABC is similar to PQR. So angle C, okay, corresponds to angle R. C corresponds to R. So if you have the bisector of C in this triangle, you must take the corresponding bisector of R in the other triangle because C corresponds with R, corresponds to R. So if CM is the bisector of angle C, then the corresponding angle here is R. So Rn is the bisector of angle R. So this is what we mean by corresponding. If you take the angle bisector of C, you must, in the other triangle, take the bisector of angle R. Medians, altitudes, angle bisector segments. Angle bisector segments meaning like here CM is a line segment that bisects angle C. Here Rn is a line segment that bisects angle R. And the bisectors are of the corresponding angles. The bisectors are of the corresponding angles. So what you have to prove is we have three things. Now we know that okay, in two similar triangles, corresponding sides are proportional. Okay. In two similar triangles, the ratio of the corresponding sides is the same as the ratio of their corresponding medians, altitudes, angle bisector segments. We know that in two similar triangles, corresponding sides are proportional. So that's one thing that you know. Now, in two similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding medians. See, think about it. When you say the two triangles are similar, you know, we know that their corresponding sides will be proportional. Okay, let me just take an example, children. 1 minute, 1 minute. Okay, let me take that example here itself. Now see here. Now say this is triangle ABC. Okay, this is triangle PQR. Okay. Now let me call this one 3, 4, 5, for example, and 6, 8, 10. So clearly the two triangles are similar because you can see 3 by 6, 4 by 8, 5 by 10, ratio is 1 by 2. So you will find PQ by AB, 3 by 6, 1 by 2, QR by BC, 4 by 8, 1 by 2, PR by AC, 5 by 10, 1 by 2. So by SSS similarity criterion, the two triangles are similar. Now what more? So we know now the two triangles are similar. Now, what is the ratio of their corresponding sides? 1 by 2. The ratio of their corresponding medians also will be 1 by 2. Now, if I take the median from P, if I take the median from P on QR, this median corresponds to the median from A in the other triangle. This median, because angle P, that is the vertex P, corresponds to the vertex A in these two triangles, because PQR is similar to ABC. PQR is similar to ABC. Vertex P corresponds to vertex A. So if you take the median from P, from the vertex P, you must take the median from the corresponding vertex A. And what is the ratio of the corresponding sides? 1 by 2. So the ratio of the corresponding medians will also be 1 by 2. So for example, say this is something like 6, not 6. Okay, just for example, children, 6 centimeters. Then this one will be 12. If supposing PM, the length of the median PM is 6 centimeters. Supposing the length of the median PM is 6 centimeters, then the length of the length of the corresponding median AN in the other triangle will be 12, because the ratio is 1 by 2. Everywhere that ratio will be maintained. Now, if you take the altitude from A, the altitude from, okay, you take the altitude from C, okay, the altitude from C. You take the altitude from C. And supposing that altitude is, say, like 15 centimeters. Okay, now the corresponding altitude in the other triangle will be the altitude from R, because C corresponds to R. C corresponds to R. If you take the altitude from C here, you must take the altitude from R here. So the altitude from R like this, it will fall on the opposite side like this. Now, what do you know? This altitude, the length of this altitude is 15 centimeters. So what will be the length of this altitude? I'll take a short nap. You think and tell me. What is this, children? What are you doing? Not following, is it? What happened? Please say something. No, you please clarify one thing. Are you following or not? I'll repeat it, but let's not waste time. I can't sit idle, please.
Your presentation is not visible to me.
From when, Ram?
From 10 minutes before only.
And when do you plan to say this, Ram?
I think
For the last 10 minutes, it's not visible to you, but you did not mention a word to me. What about the others?
It's visible, ma'am.
Okay. And what about
Visible.
the answer to... Okay, what about the answer to my question, children?
You can leave and join.
Yeah, you can leave and join. Yeah, the lobby is open. You can leave and join.
Yes.
You're all having your dinner. Your mouth is full. You're not able to talk. Oh my God. Is it visible now, Ram?
Yes, ma'am.
Oh my, you should have done this, no? Earlier.
Sorry, ma'am.
How? No. See, I'm feeling sorry for you. You don't have to say sorry, but you're managing for 10 minutes. Now, I want each of you to say something, children. Just ask yourself, are you doing the right thing? Is it fair on your part to be like this? Huh? I'm literally begging you all to open your mouth and say something.
Ma'am, last few minutes my grandmother called, ma'am, so I went, ma'am.
Okay. What about others? We are wasting time, you know. I'll tell you, you must have heard this in school also, teachers telling that this is the worst class I have ever seen and all that. Seriously, I'll tell you, you know, for the last 2.5 years, I've been taking online session. Only this year, the class is so quiet. Nobody is interested in answering. Or either you have some mic issue. It's completely new. The 9th and 8th standard students, they interact. There's at least one person talking. This class, even after this,
I'm sorry.
the others are least bothered. You're enjoying your dinner?
No, ma'am.
Okay, Priyanka and Harini. What about the others? Okay, fine. I don't want to waste any more time. So, what is the question? Tell me that. What is my question? No, I think I must take you people to task. Yes, I think so far Nandini, Ananya, and Rajarajeshwari haven't answered at all. Why are you quiet? Are you following or not? Answer that, Nandini.
Yes, ma'am.
You're not following?
I am following, ma'am.
Then what is the answer, darling? Ananya?
Ma'am, you call me? Ma'am,
Yeah.
your voice has been breaking for the past 15 minutes. I don't know. I cannot exactly hear what you do.
Okay. What about Rajeshwari? Rajeshwari? Okay, fine. My question is, if the length of the altitude CP, not CP, okay, forget it. If the length of this altitude is 15 units, what is the length of this altitude is my question. Yes, Nandini, you said you're falling. Tell me.
Ma'am, can you repeat the question, ma'am?
I'm not repeating the question. I'll repeat the whole thing. What was I telling? Tell me. In two similar triangles. In two similar triangles. Ananya, are you following me? Meaning, can you hear me? In two similar triangles, the ratio of the corresponding sides. Ananya.
Did you call me?
Yes. Yeah. Is it clear now, or there's still some problem?
Ma'am, I can't hear you clearly.
How do you manage, Ananya? Does it happen frequently, or in a meeting, does it happen frequently or rarely?
I can't hear you entirely.
Oh, okay. In two similar triangles, the ratio of the corresponding sides is the same. Rajeshwari, you have to reply later. I asked you a question. I did not get any reply from you. You have to answer me later. It's the same as the
corresponding.
Ram, are you able to see the screen?
Yes, ma'am.
Okay. In two similar triangles, the ratio of the corresponding sides is the same as the ratio of their corresponding
Sides.
This is corresponding sides. The ratio of the corresponding sides is the same as the ratio of their corresponding
Altitudes, medians.
Altitudes, medians,
Angle bisector segments.
angle bisector segments. Angle bisector segments. See, angle bisector segments is nothing but the bisectors of the angles. Line segment, no, so segments, lines, everything. Altitude is a line segment, median is a line segment, angle bisector, that line segment, angle bisector segments. Triangle, ABC, triangle, PQR. It is given that triangle ABC is similar to triangle PQR. That means angle A corresponds to angle P, angle B corresponds to angle Q, and angle C corresponds to angle R. These are the corresponding angles. Let me consider the median from B on AC. BM is the median from B on AC. Angle B corresponds to angle Q. So you must take the median from Q in the other triangle. Let Qn be the median from the corresponding angle Q to the side PR. Now these two triangles are similar. These two triangles are similar. It is given. Now let me just mark something. This is 12. This is 4. Okay. Now in two similar triangles, the ratio of their corresponding sides, this is the ratio of their corresponding sides, AB by PQ, is the same as the ratio of their corresponding medians, is equal to BM by QN. The ratio of their corresponding sides only in two similar triangles, not in any two triangles, only in two similar triangles.
Ma'am, ma'am,
Oh, sorry, children, I had to pick up the call. Yeah. Continue. So I was telling you that, yeah, according to this statement, in two similar triangles, I told you that ABC is similar to PQR. In two similar triangles, the ratio of the corresponding sides AB by PQ is the same as, meaning is equal to the ratio of their corresponding altitudes, medians, angle bisector segments. So here we have the medians. We have the medians from the corresponding vertices B and Q. So is equal to BM by QN. So how much is AB? 12 by PQ 4 is equal to BM by QN. So the ratio is 3:1. So the ratio is 3:1. So the ratio of the corresponding sides is 3:1. The ratio of the corresponding medians also will be 3:1. The ratio of the corresponding medians also will be 3:1. Like for example, if this is say 2 centimeters, what will be the length of BM? 2 units. If QN is 2 units, what will be the length of BM?
Ma'am,
Yeah, somebody said it right. Yes. Again, you people are not answering. My God.
6, ma'am.
Louder?
6, ma'am.
6. Where were you, Rajeshwari? All the while? I asked you. I called out so many times earlier.
Ma'am, my laptop got hanged, ma'am. I couldn't respond, ma'am. I rejoined again, ma'am.
So it will be 6. Now let's consider the corresponding medians. Let's sorry, the corresponding altitudes. Let's take the altitude from A. Let's take the altitude from A. So the corresponding altitude here will be from P. From P. So again, the ratio of the corresponding sides, you can take anything. See, you can take BC by QR also. The ratio of the corresponding sides, BC by QR. Any ratio you can take, AB by PQ, BC by QR, AC by PR, any ratio. So the ratio of the corresponding sides is the same as the ratio of the corresponding altitudes. So if I call this Y and Z here, corresponding altitudes are AY and PZ. The ratio of the corresponding sides, BC by QR, is equal to the ratio of the corresponding altitudes. Why AY and PZ are the corresponding altitudes? Because AY is from the vertex A and PZ is from the vertex P, and A and P are corresponding vertices. So AY and PZ are corresponding altitudes. So since this ratio BC by QR is 3:1, this ratio also will be 3:1. AY by PZ also will be 3:1. So now tell me, if AY is 9 units, how much is PZ?
3, ma'am.
3 units. It will be 3 units. Is the same as the ratio of the corresponding angle bisector segments. Angle bisector segments. Now, okay. So now let's take the bisector of angle A. Okay, ABC is similar to PQR. Is given. Let's take the bisector of angle A. The bisector of angle A. So when it's the bisector of angle A, that means this part is equal to this part. This angle is equal to this angle. So angle A corresponds to angle P. So if you have the bisector of angle A here, then you must take the bisector of angle P here. The bisector of angle P here. The bisector of angle P. Now these are the corresponding angle bisector segments. AM is a line segment, PM is a line segment. What kind of line segment? Angle bisector segments. So again, ratio of the corresponding sides. So you can take, say, AC by PR also. The ratio of the corresponding sides is the same as, meaning equal to, the ratio of the corresponding angle bisector segments, AM by PN. So these results you must remember. You might get some numericals based on these results. Is it clear, children?
It's on the angle bisector only.
Angle bisector?
I can't understand, ma'am.
Okay. Okay. So triangle ABC, triangle PQR. They are similar. You know that they are similar. Now, Harini, then which are the which is the vertex that corresponds to angle C in the other triangle?
Angle R, ma'am.
Angle R. Now, supposing this is say, for example, this is 50 degrees. Then if you take the bisector of angle C, it will become 25 degrees here and 25 degrees here, right?
Yes, ma'am.
So we say that CM is the bisector of angle C. So here, if this angle is equal to this angle, here also it should be 50 only because they are corresponding angles. It should be 50. So it'll be 25 here and 25 here. So that means Rn is the bisector of angle R. Yes or no?
Yes, ma'am.
So that means the bisector CM corresponds to the bisector Rn.
Got it, ma'am.
Now tell me the ratio of the corresponding sides. Any ratio. Tell me the ratio of the corresponding sides.
Ma'am,
Yeah.
CM by RN
Ratio of the corresponding sides I'm asking.
AB by PQ.
AB by PQ. The ratio of the corresponding sides is the same as, meaning equal to, is the same as the ratio of their corresponding angle bisector segments.
CM by RN.
CM by RN. These two ratios are not only these two ratios, AB by PQ or BC by QR or AC by PR, any ratio you can write is equal to CM by RN. All right?
Okay.
Yeah. Yeah, that's what it is here, children. We need to prove that the ratio, the ratio of the corresponding sides is in two similar triangles. Okay, prove that in two similar triangles. Please write down like this. Yeah, take down this. Prove that in two similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding medians. Write down this. We'll wind up today's session with this one. Okay. So we are given that triangle ABC is similar to triangle DEF. This is given. AM and DN, because you'll have to prove that it's the same as the corresponding ratio of the corresponding medians. So you take up any two corresponding medians. So AM, you don't have, it's not that you should take AM. If you take BM, then you should take EN here. So AM and DN are medians on the corresponding sides. We have to prove these results. We'll have to prove that this one, and this one. I think I asked you to write a statement now, no? Just take away that, erase that. You can just, I've written prove that here itself. I told you the three results. I hope you took down, you have taken down this one. Where did that go? Yeah, these are the results. In two similar triangles, the ratio of the corresponding sides is the same as the ratio of their corresponding altitudes, medians, angle bisector segments. Yeah, so here, just treat this like this. The figure is given to you. The figure is given to you. And then you know all this. This one, you know. You'll have to prove that all this. Okay, are we ready? We'll have to first prove the triangle. Yeah, very good. We'll have to prove that ABM, this triangle. What information is given, children? The whole triangles are similar. ABC is similar to DEF. That's given. We have considered the medians AM and DN from the corresponding vertices A and D on the corresponding sides BC and EF. Okay, we need to prove these results. ABM corresponding, sorry, similar to DEN. So in the two triangles, children, you'll have to show that these two triangles are similar to each other. Now we already know that AB by DE is equal to BC by EF, correct? Because ABC is similar to DEF. Yes or no?
Yes, ma'am.
Yeah.
Yes,
ma'am.
Yeah, since ABC is similar to DEF, we know that AB by DE is equal to BC by EF.
Ma'am, we can use the property also, ma'am.
What property?
Ma'am, the corresponding altitudes and medians are equal, no, ma'am.
That you can use directly to solve numericals. I just told you all those three results. Now we are seeing how to prove them.
Okay, ma'am.
Yeah. I told you the three results. We're just seeing how you have to prove them. Okay. So to prove that the triangles are, to prove that this triangle is similar to this triangle, take up the two triangles and write out what you know. What do you know? So you know that AB by, because the triangles are similar, the whole triangle is similar, AB by DE is equal to BC by EF. Now BC can be written as 2 times BM, correct? Because M is the midpoint. It's the median, so M is the midpoint. You can write BC as 2 times BM because M is the midpoint. And you can write EF as 2 times EN because N is the midpoint. Now 2 and 2 will get cancelled. So you get a new proportion. AB by DE is equal to BM by EN. BM by EN. So just see where you find this this proportion or this ratio in the triangles. When you find here, AB by DE is equal to BM by EN. So now you know that the included angles are equal. This angle is equal to this angle because triangle ABC is similar to DEF. So we already know that angle B is equal to angle E. So by SAS rule, the two triangles are similar to each other. That's how you prove that this triangle is similar to this triangle. Next, you'll have to show that BC by EF is equal to AM by DN. Now that these two triangles are similar, you can write AB by DE. AB by DE is equal to AB. You can write, now that you've proved that these two triangles are similar, which two here, these two triangles are similar, you can write AB by DE is equal to AM by DN. These two triangles are similar. These two triangles are similar. So we know that AB by DE is equal to AM by DN, sorry. Oh, not, oh, sorry. Oh, I finished the first part, right? See, now I'm confused. I finished the first part. Yes. I already told you that these two triangles are similar. This triangle is similar to this triangle. I already told you that. I'm sorry, I just lost track of what I was telling. We have to first show that this triangle is similar to this triangle. For that, we know AB by DE is equal to BC by EF. And BC can be written as 2 times BM. And EF can be written as 2 times EN. So 2 gets cancelled. So we have this ratio AB by DE is equal to BM by EN. AB by DE is equal to BM by EN. And this angle is equal to this angle because already ABC is similar to DEF. So the corresponding angles are equal. Angle B is equal to angle E. So from 1 and 2, this triangle is similar to this triangle by SAS rule. Now we'll have to show that BC, see AM by DN is equal to BC by EF, BC by EF. So that's again simple because we just because these two triangles are similar. Since these two triangles are similar, we have AB by DE equal to BM by EN. Oh, altitudes we'll have to prove, right? Altitudes, okay. So we know that AB by DE is equal to AM by DN because the two triangles are similar. We already proved here. AB by DE is equal to AM, altitude AM, not altitude, median AM by median DN. We already know that. But AB by DE is equal to BC by EF. Because the two triangles are similar, AB by DE is equal to BC by EF. So you can replace, instead of AB by DE, you can write BC by EF. So BC by EF is equal to AM by DN. Thirdly, we will have to show that AMC, this triangle, is similar to DNF, this triangle. These two triangles are similar. See, to prove that this triangle is similar to this triangle, you can say use the same rule. You can use the same rule, this one here. The same rule you can use. Yeah, in the same way, like you prove the first one, you can prove the third one. But you have many other ways also. Okay, you have other ways also. Now that these two triangles are similar, this angle is equal to this angle. So that means 180 minus this will be this angle. 180 minus this will be this angle. So this angle is also equal to this angle. I'll just number 1, 2 here and 3, 4 here. Now, angle 1 is equal to angle 2. Why is angle 1 equal to angle 2? Because we have proved that this triangle is similar to this triangle. So that corresponding angles are equal. Angle M will be equal to angle N. Corresponding angles are equal. So angle 1 is equal to angle 2. So 180 minus angle 1 will be equal to 180 minus angle 2. 180 minus angle 1 is equal to 180 minus angle 2. 180 minus angle 1 is angle 3. And 180 minus angle 2 is angle 4. So like this, you get 3 is equal to 4. So 3 is equal to 4. So in this triangle and this triangle, angle 3 is equal to angle 4. And also angle C is equal to angle F. C is equal to F because the triangles are similar. The whole triangles ABC and DF are similar. 3 is equal to 4. So double A similarity, the two triangles are similar. You can prove it like this. There are many other ways. It's time. We'll see this again in the next class. Take a screenshot of this one, children. Please complete this in your notebook. Yeah. This one. Take a picture, children. Done?
Yes, ma'am.
Yes,
All right,
ma'am.
children. All right, children. All right, children. So that's it for today's session. Thank you. Good night. You may leave the call.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you. Good night.